by middle of October, you need to announce your project through like a Google form. And this is really mostly for us to understand who are the teams there. We'll be using the Canvas team, the group feature this year. And then you need to submit a project proposal like somewhere around the end of October. And I would really suggest that you guys like meet up as a team and use, like if you're not traveling, use fall break to get started, or like really think about this. And also it's important that you talk to us and to your TAs about projects. Like if you feel like, hey, I have this great idea, but you aren't completely sure about it, then we can probably help you figure this out. So what you need is a team, and if you don't have a team yet, either like talk to people in class or use the looking for team member channel on Slack. When you post there, say like who you are, what you like to do, what your interests are, and then any potential ideas or data sets that you have. Of course, you need an idea of what you want to do. Yeah?
What's the team size? Team
size is 2 to 3. We do make rare exceptions for single-person teams, although that's only for very good reasons. For example, if you're taking this class mostly remote, or sometimes we allow 4-person teams, but then we have like pretty high standards on what the project is going to be. Like one important thing is a data set. Like an idea is like important, but even more important is a data set. And it's actually a data set that you can get. Like I've supervised a project when I was a TA a while ago, and these guys had the brilliant idea of analyzing Supreme Court decisions by parsing like lots of PDFs. It turns out parsing PDFs is pretty hard. And they ended up not being able to do that project and had to switch like 1 week before the deadline to a completely different project. I did warn them. I'm warning you very explicitly now. Like if you need the data set, you need some scraping or something like that, just like be sure to explore early whether you can get whether you can get this data set. Like here we have a couple of data resources on the website. There's like really good data from things like the United Nations or many governments, including state and federal governments. And generally, I would really recommend that you read the project page because this kind of like describes the whole process in more detail. And kind of like what's on there is what counts. Okay, so what are the stages of the project? So first, you have to announce it, and this is really mostly administrative for us. Then you have to put in a proposal, and the proposal really just like lays out what data sets do you want to do, what visualizations are you planning, like sketches, designs, and so on. Alternative plans, like what are your like ambitions, what are the must-have features, and so on. So all of this should be part of the proposal. There are some templates, I think, on the project side. If not, remind me on Slack. I'll post some templates from previous years. Project milestone is really like here you submit code that does work. And the milestone really is supposed to give us a chance to work with you, to give you feedback. So we'll not be super strict in terms of grading. Like your design isn't like grade is not going to be something that you'll hear from us. We'll be more strict about grading here in terms of scope. So like you should really at this point have the scaffolds of your visualization up, and you should have your data like working and accessible. General comment, I would recommend that you try to like avoid very big data sets because you do not want to necessarily deal with the client-server architecture. This is going to make your life a lot harder. Like, we don't like oppose it, but generally like try to find a data set that you can easily load in the browser and where you don't have to like load data from a server. We're not even talking about this in this class, and so you would have to figure this out by yourself, and it will make your life a lot harder. And then after the project milestone, yeah.
What size would that be?
Like I would say that anything in like less than 100 megabytes is probably 1,000 or 5,000 rows are already a lot for your visualization, but it depends on how you want to design it. But essentially, like when you want to visualize whatever, like whole genome data, clearly this is not going to work just on the client, right? So you have to think a little bit differently about it. And for your final project, we kind of like want you to like submit the code and publish your website. Like since we all build interactive websites here, You need to write the process book. So essentially, this is something that you should this should evolve out of your project proposal. So you start out with a proposal, and then you continue like documenting what you're doing. Like think of it as a lab notebook. And then in the end, you have like this nice process book that describes your everything that you did and your result, and justifies why you did stuff like you did it. We want you to record a video and narrate that. So you should kind of tell us a story about how to use your visualization. And that's supposed to be 2 minutes or less. And yeah, as I already mentioned, the visualization should be live on the website. Okay, any other questions about projects?
Live on the website?
Like, yeah, publish on GitHub pages or something like that. Like, we want to be able to access it through a public URL. There are reasons for to not do this, right? Some people have data in their research projects that they don't want to publicly share. If that is the case for your project, just come talk to us. We can accommodate that. But by default, we would like every project to be publicly hosted, and ideally through like a service that you don't have to pay for, like GitHub pages, because we kind of like link to the best projects, and the best project from 5 years ago are much more likely to be alive when you don't have to pay for the web server. Okay, two things that I should add is like we really want you to tell us a story about a data set. We'll talk more about storytelling, but it's not supposed to be just like a visualization technique where you upload any given data set of that form. But we kind of like want you to do something a little bit more journalistic, like something like you see in the New York Times with narration. You can like write a little bit of text and so on. And we'll talk about how to do this in the future. And then the other thing is that, well, yeah, here are some requirements. So if you're unsure about the scope, just talk to me or to the TAs, come to office hours. I would like you to challenge to be ambitious. And define your goals and categorize them as like must-have, nice-to-have, and so on. Check out our Hall of Fame from the last couple of years to get a reference point of what a good project is. But at the minimum, we want you to have like an original idea of a data set visualization combo. So we don't expect you to create like a novel visualization, but you should do something in a way that hasn't necessarily been done before in this combination. It does need to be interactive. And we do require you to have at least 2 coordinated views. So there should be 2 different components that speak to each other, where you can do something like linking and brushing or some highlighting. There are exceptions to this. If you have like super fancy like single view visualization, that we're not going to hold you to that. But essentially, this would be kind of like your default for that. Okay, and also think a little bit about like don't just do like here's a parallel coordinates plot that Mike Bostwick wrote 8 years ago, and I'm going to just show this, and then another view. Think a little bit about custom visualization. So here is like a custom visualization that you will be implementing for your homework 5, and that's kind of a good example of the kind of visualization that we are looking for. Like this video of it. So this is about the World Cup, the soccer World Cup in Russia, and this is basically a table where we have these custom visual encodings for goal difference. We can sort this very interactively. You can expand like every country and see its opponents. And all of this links to a tree. And so here you have all of those things that I just talked about, right? It has 2 different views. They communicate with each other. They're synchronized. And you have like a custom visual encoding here. Like clearly this wasn't copied from some blog. But instead, this is really like tailor-made to this particular data set. So we just released this homework, and there will be like a lab about it next Wednesday, and it's due 2 weeks after it's released, but 2 weeks after it's released is the Friday before fall break, and so we're actually making it due at the end of fall break, Friday at the end of fall break. So that's 3 weeks of time, 2 weeks of class time. So if you're going on a trip or something like that over fall break, you should wrap this up before fall break. And still have 2 weeks to do, but otherwise, if you're around and not doing anything else for fall break, you can work on your homework. Okay, so next week, since you'll be using a tree, they will be talking about designing visualizations and tasks. and I need you to read this paper, and we'll have a class discussion about it again. Great. So any administrators' questions? Great. Everybody doing fine on homework 4? Okay. Let's talk about interaction. So, what is interaction? Like, why do we care about interaction? So first, there's the spectrum. We have static content, like infographics that somebody posts on Twitter, on Pinterest, or whatever, or books or papers. Like, this is kind of like where statistical graphics and visualization comes from. But nowadays, we also have dynamic content. And dynamic content is really where computers come in. And dynamic content can either be like animated content, like videos on autoplay, or like a visualization on autoplay, or it can be truly interactive, where we make changes as a result of some user action. So you click somewhere and reveal details about that or something like that. And why do we want to use interaction in visualization? So, like very often it is like the case that data sets are like fairly big and complex, so that you can't really show every facet of it without leveraging interaction. You might either have too much data, or there are too many ways to show it. Just remember this visualization. If we looked at the tax rates, corporate tax rates for US companies, there's a couple of forms of interaction in here. Like first, we have a tooltip, right? And you've all implemented tooltips already. That's like one form of interaction, because we are revealing information and data about these items. But then this also has like recall that we had this this here on the x-axis we have the effective tax rate for these corporations. But if we try to encode like industry information here, we could try to like do bubbles, right? Like bubble color, but that would be kind of like pretty colorful and not very clear. And so now what you can do here is you can interact and switch to this view by industry. And now I have kind of like, by using this interaction, I first had an overview, and then I have triggered an action, and that is animated into this like split up view where I can now explore a different facet of the data set and can compare things. But overall, this wouldn't be like a great first visualization, right? Because this kind of gives you a nice overview, and this here is a super complementary view. And by being able to switch between the two of them, you get more out of it than if you had just one of those. So interaction also amplifies cognition. Just think about if you get like a puzzle, like one of the 3D puzzles that you need to assemble in some way. Like you're not just going to leave it on the table and look at it, figure out the solution, and then do it. You're going to touch it and try things and play with it. This is how we learn and how we understand things. We can't really physically touch visualizations, but we can interact with them through a screen. So here is like an example, and we'll talk a little bit more about this when we talk about dimensionality reduction. But this is like a simple visualization of principal component analysis. And so here we have an original data set, and then we have the output of the principal component. You can see this is like a linear relationship, so we have like most of the variance is covered in our first principal component. But now I can actually manipulate those data points, and kind of like that tells me the output of the principal component analysis. And so kind of like I can get a sense of what the principal component analysis does by interacting and rearranging those points, right? I can build an intuitive understanding of what is going on. Just like I would assemble like a physical puzzle with my hands, I can play with this and try to understand what principal component analysis is doing. So we can observe cause and effect if we trigger something. That is like a super useful relationship. You can't talk about interaction and not mention Minority Report. Who's seen the movie? Most people, okay. Minority Report is really all about Tom Cruise swiping through the air, who will be like the criminals of the future. So what do we use, we need to think a little bit about interfaces. Like what do we design for? That really matters a lot. Like are we designing for mouse and keyboard? Are we designing for touch interactions on a tablet or a phone? Are we like designing for gestures? Do you want to have in-air gestures? Or is it even something more subtle than that, by eye movement? There's like a lot of interesting research about eye tracking. Or even speech input. And I just want to play this one video about, the title of the video is Why I Hate Tom Cruise.
Hi, I'm Alex Kaufman. I'm an interaction researcher, which means that I explore and prototype future uses of technology as a way of understanding the future. And I really, really hate Tom Cruise. I specifically hate Minority Report Tom Cruise. With his perfect haircut and his power stance, chopping at the air to sort of scroll through scenes of crimes that haven't happened yet, because it has conditioned us to expect that the future of gesture interfaces is going to look dramatic. You know, all the gesture tech we're building, the leaps, the connects, the Mayos, they all demand these highly visible gestures that are distracting us from a more pedestrian, less cinematic future that is definitely more usable than this. I mean, every time I see this scene, I think, Tom, you're standing 2 feet away from the screen. Why don't you touch it? He's replaced direct manipulation, which our hands are really good at, with this kind of elaborate sign language, which our hands are really bad at. It's as if I said, like, it's the difference between solving a Rubik's Cube and explaining to somebody how to solve it by pointing. And the thing is, our hands are very coordinated. I mean, you can be walking down the street and pick up a penny without breaking your stride. But unless you're a mime or a dancer, you're going to have a really hard time pointing at the same spot in space twice in a row. And anybody who's ever used a Wiimote knows it's really hard to point precisely. But I think there's a feeling among people that somehow getting rid of a controller makes an interaction feel more natural. And people become so obsessed with this idea of getting rid of the mouse and replacing it with gestures that they've actually forgotten how we use our hands. Because most of the time, we're not gesturing. In fact, 90% of gestures occur when we're speaking. And studies have shown that all of those gestures, almost to the last one, are for the benefit of the speaker. They help the speaker keep track of what he is saying. They convey no useful information to the audience. Now, I'm not saying that we can't use gestures and interfaces. What I'm saying is that we've got to pay attention to what their unique characteristics are. They're fast, they're silent, they can be performed at sort of any variety of distances, and most importantly, they have this kind of inherent directionality. So at least in theory, you could use gestures as this kind of meta-unifying input across a series of devices. And what I mean by this is, for instance, if I point at my stereo and it turns on, and then I point at it and it turns off, and then I point at my TV and it turns on, and I point at my TV and it turns off, I've actually established a common language that both of these devices understand. And I can use this language as a way to connect them in a very intuitive way. So, for instance, if I point at both my TV and my stereo, if the TV is on, it pipes the sound to the stereo. Or if the stereo is on, it actually pipes the music video of the song that was playing or the album art. This all sort of presumes that gestures are these explicit and very deliberate motions. And I think actually the real magic happens when the applications start to pay attention to what we do with our bodies normally, what we do with our hands normally. Because once machines can interpret our normal motions, they can find some insight into our intentions. And machines that understand intentions can actually start to help us.
Okay, so I don't want to show the rest of this, but like you probably all heard of this Leap Motion startup, right? And that kind of like was a big deal a couple of years ago. As it turns out, they did fizzle out eventually. So it's really tricky to get this right, and I just saw this yesterday here. This is an announcement for the new Google Pixel 4, and now you will have in-air gestures to progress your playlists. Could be potentially useful when you're cooking and put this on your stand, right? But this is not usually how you interact with people. So just like the point of all of this is really just be very deliberate about how you're interacting or how you implement interactions, and like think about if you use something like gestures, like what are the pros and cons of it? Is it really the best way of interacting with it, or are there other easier ways to go about this? One thing that is really like kind of like the thing that people try to do nowadays with interaction is what's called direct manipulation. So like what that means, like it's easiest explained like indirectly. So first, like indirect manipulation is you have a slider somewhere on an interface, and that slider, like in whatever user interface library you're using, that controls something on the screen. Direct manipulation is the opposite. You directly interact with the data point. So here's an example of direct manipulation. This is an observable notebook, and so here I can like draw a brush and directly move the brush around the space here, right? Like indirect manipulation would be if I had a slider here for like what is the range of data that I want to select in X, and what's the range of data that I want to select in Y. But direct manipulation is much more powerful, right? Because you immediately understand the cause and the effect of the manipulation. And you do also want to give continuous feedback and updates if you implement direct manipulation. And so we'll see many examples today of this direct, but also of indirect manipulation. So if we think a little bit more about what are the types of interaction, we can classify them by either being for a single view or in multiple views. And we'll talk more about views. Again, I already mentioned this concept of having multiple views to show different facets of the data, but this is an important distinction for visualization and also for interaction. So in a single view, you have change over time, you have navigation, you have semantic zooming, filtering and querying, focus and context. And this is kind of like how the rest of this lecture is structured. And on the multiple views, you have selections and details on demand, linking and brushing. This is what I just did with this observable notebook, right? I brushed in one of those scatter plots, and all of the others were linked and updated, and then adapting representations. So we'll talk about these things here mostly when we talk about multiple views in the future. So now I want to kind of like talk a little bit about the paper that I asked you guys to read. So anybody want to summarize it? Brief summary, like three sentences, what this is about.
So the gist of the paper was organizing the different types of interactive, or like different types of interactions you have with visualizations.
Yeah, exactly. So we have different types of interactions, and these are the types that I'm showing here. And like I think that you mostly think about view manipulation initially when I talk about interaction. Right? That, like stuff that I just showed, like brushing, is really about selecting items to highlight. So this is like a fairly a space that we understand well, or navigating. Like if you have Google Earth and you want to zoom and pan around, this is also in a view manipulation space. Or if you like drag around, like if you work on a paper and you look at some references, you have those windows over there, you move windows around, this would also be view manipulation. Can somebody give me an example of data specification? Yeah. When you filter
your data so that you can get more specific.
Yeah, you could think of it like this. You could say, hey, I want to like just this subset of my data, or maybe I even need to select the data set that I want to show in the first place, right? Like a view specification example. So, for example, if you create a plot in Excel, you like pick some data points from some table, and then you interact with different representations, right? Do I want a bar chart? Do I want a pie chart? Do I want a scatter plot, and so on? So this would be like a visualization specification. So this is kind of the first point here: visualize data by choosing visual encodings. And then, can anybody give me an example of the process and provenance category?
Telling a story in the New York Times.
Yeah, telling a story in the New York Times is like one aspect of it. Here you kind of like have like annotations that are prepared for you.
This could also be where you use the user's intelligence to label your data.
Yeah, so annotations. So basically, when like an analyst looks at some data set and sees something, and then they select those points and say this is like an important finding or something like that. But the simplest example, I guess, And this category would be like your undo redo stack that you have in like most software tools nowadays. So yeah, I think that this paper, like if you haven't read it, like definitely read it because it's like a very accessible introduction to the different types of interactions. Okay, so I want to go through those different types of interactions next. So first is like a change over time or transitions. Like if I want to show how like a data set, for example, evolves, I can use sliders to see a view with data at different times. So here is like actually a student project from a while ago, and this shows us like a couple of things. First, it shows us like which states were part of the Union according at a certain time. So we are looking at 1800. So like there were only eastern states in the Union, and then it shows us railroads, the progress of railroads. And I have this year selector filter here, and I can say like, okay, after like in 1810, we don't really see any railroads yet, but there have been like a state has been added. Then if I go into the next year, we have more states, and we start to, like it's a little hard to tell, but here are some railroads that are appearing. And if I keep dragging, you can see that more and more railroads are appearing, more and more states are added. And now we're starting to see like a railroad network here. And at this point, here we have like the transcontinental railroad development. So here I could like do this direct manipulation, or no, this is actually indirect manipulation, but here I could manipulate time manually and like take time to read whatever the story here is about. But I can also do like play a sequence just to get an overview of what is going on in the first place, and then this will automatically step through those different time frames and show us kind of the growth of the railroad network and of the states. However, like just remember, like when I showed you this animation about fertility rates in Japan and the US, like that was like an animation, right? But it was fairly tricky to keep track of. So sometimes it's really better to show differences explicitly, either by doing like two views, like as time 1, time 2, or by like actually calculating a difference and showing that difference. And change over time doesn't have to be literal time. It can also be things like that you change as you go, for example, as part of an analysis process, as you kind of sort things and so on. So when we do stuff like that, we often, like, it's usually not the best idea to like let a user interact with the tool and then throw out like some new ordering or sorting without any kinds of transitions. And so we've seen that D3 supports these transitions very easily, but why do we actually care about these transitions? So there's many reasons actually, but mostly it's about people understanding what's going on. So here is like a tool, and I'll talk more about this when we talk about set data, but this basically shows us overlaps between different movie genres. And so I could ask a question of like, which kind of like other genres do action movies interact with frequently, or adventure movies? And I have like these, I can click on this and immediately see the sorting update, or here I could sort by size or by some like statistical measure, and so on. So there's many ways, and notice that all of these like lead to transitions, and so that kind of helps me keep track of what is going on and gives me like a sense of agency here. So transitions make it possible for users to really track what is going on, like there's lots of different types of transitions, right? And like developing good animated transitions is actually tricky for special cases. Here's an example for like a tree visualization, which I'll also talk about in a later lecture. But this is essentially, you have like the back, like the overview is what you see here, and then I click on segment, and that segment pops out and appears. And so it's kind of intuitive to understand what's going on. Or similarly, like we talked about the advantages of like stacked bar charts and group bar charts a little bit when we talked about designs. It's easy to like make a transition that makes people understand the relationships between the two of them. So you can simply switch dynamically and see how these stacked bars are created. And this is again implemented in V3 here. So why do we people have of course asked this question, how much of this animated transition is too much? Why do we care? And so there is this study here and this video that introduces this problem.
When analyzing or presenting information using statistical data graphics, it is common to look at a number of related graphs. For example, the viewer of a bar chart may want to switch to a pie chart to view relative percentages, transition to a scatter plot to look for correlations between two variables, or drill down by breaking up the data by categories. Animation is one promising approach for facilitating perception of changes when transitioning between data graphics. Using design guidelines motivated by research of human perception, we have developed Dynaviz, a system supporting animated transitions for statistical data graphics. Dynaviz provides animations for a number of different transition types, including changes of perspective, filtering operations, and viewing changes of data over time. In some cases, changes of value require changing the axis scales. Here we show a sorting operation. Animating everything at once can result in items occluding each other. By slightly staggering the movement of each of the bars, Dynaviz makes the sort easier to follow. Here, a bar chart becomes a radial donut chart. By growing the wedges to take up the whole circle, we form a pie chart. We can also perform drill down operations, breaking up the data further into distinct categories. We can then unstack the bars to view the same data as a grouped bar chart. Of course, we can always reverse the transitions to return to the view we started with. We might want to compare different variables in a scatter plot to look for correlations. Here, we keep the y-axis values the same as the bar chart, but use the x-axis to show a new variable. Animation is also helpful for showing transformations to the data. Here we show applying a base 10 log transform to the data. Both data and axes smoothly animate to show the results of the transform. Visual encoding such as shape, color, and size can be used to visualize additional data dimensions. To evaluate the use of animation in data graphics, we ran two controlled experiments. The first experiment asked users to follow two targets across an animated transition and click their final position. To better test how animation affects memory, we masked the display after the transition by turning it black. We compared static transitions, direct transitions in which all items animate at once, and staged animations where movements were split up over time. Our results found significant benefits for animation and found that staged animations, which split up movements through staggering or separate stages, consistently improved accuracy. The one exception was for changes in a scatter plot, where two quick transitions in a row were more difficult to follow than one longer transition. The second experiment asked users to follow.
So, what are the kind of if you see these kinds of animations, these very nice transitions, anybody want to speculate on the limitations? Yeah.
If you have too many data points, it's going to be overwhelming.
Exactly. So if you have too many data points, staggering is not going to make a ton of sense. So if you have 500 data points, then clearly this is not going to help you that much. So all of these examples are very small examples, but 10 power bars or something like that. There's actually a follow-up paper. The title is kind of cool, the not so staggering effective staggering animations. They kind of looked a little bit at the limitations of that. So also going back to this tool that I just showed, we actually found that here we have a fairly small data set, but if we keep adding sets to this, we get more and more elements. And at some point, there is a lot of sets now. And if I did any animations here, it wouldn't be particularly helpful because things would just fly off the screen and then fly into the screen, right? There isn't really any meaning anymore. So we did turn off animations at a certain point. Essentially, when the majority of your elements move off screen, then kind of animation is also not particularly helpful anymore. So changes can be hard to track, and again, as with any interaction, don't forget the eyes of a memory principle. Show all states potentially in multiple views. So the type of interaction that you're also probably very intimately familiar with is navigation. Like, navigation is like the simplest like form, or in 3D would be pan, zoom, and rotate. So like, we can do this on a map. So here's like a Google map that I can dynamically, like I'm rotating, I'm panning, and I'm zooming here at the same time. And then I guess the farther I zoom in, the more details are revealed here, which is kind of like a details on demand or a semantic zooming application that I'll talk about a little bit later. But really, this is about panning and zooming. And we do this panning and zooming also in other applications. So for example, here is a WebGL implementation of a volume renderer that shows me some pathways in the brain. And I can again zoom here dynamically and pan, move things around. And I have also some other like indirect manipulation widgets in here. So this kind of like zooming and panning is super important when you have data that you can't fit in the screen. Of course, in information visualization, we often try to fit lots of things, like the things that we care about on the screen. And so panning and zooming is something that I try to avoid when I can in most of my personal designs. But if you have 3D spatial data, clearly you can't avoid that. Let me just turn this off because this WebGL is going to burn out my computer. One kind of interaction that happened in that appeared in the last like 5 or 10 years is scrolly telling. You probably all have seen this. So you don't actually click on buttons or something like that. You just swipe up and the visualization changes, or you scroll on your computer. And this is something that is really like nice, especially on mobile devices, because this swiping is much more like much more useful and well understood on mobile devices. And generally, this is like a nice idea, but there's a couple of things that you have to think about. Do you want to do continuous scrolling, or are you scrolling between discrete states? Do you give direct access to some of those later stages, or do people have to scroll through all of this without being able to jump to a specific place? And you also have to be a little bit careful about unexpected behavior when you're scrolling. So there's like a nice analysis of the pros and cons on this website here. Eagereyes.org is a visualization blog by Robert Casara. And one of our students actually did a evaluation paper on the benefits of scrolly telling. So here are a couple of examples of scrolly telling, and like maybe I'll start with this one here because it's kind of the simpler one. So this is a visualization of what is really warming the world. And so basically, this line here shows the measurement of observed land-ocean temperature, of measured or observed land-ocean temperature. So now we can scroll, and then kind of like every time we scroll, keep scrolling, we see another data set juxtaposed here, and we get kind of like this. So do we see any correlation between a particular effect, for example, the change in the Earth orbit and the temperature? And we see that the change in the Earth orbit varies a little bit, but doesn't really correlate with the line. Is it something about the sun? As the sun varies, and we see it does not. Is it like something like volcanoes? We see that there's fluctuation, but it doesn't really seem to correlate strongly. Is it like a combination of those three things? It turns out it is also not that. So is it deforestation? It doesn't seem to be deforestation. Or ozone? It's neither, and so on. And we can keep going, and then, of course, at the end, we'll see that it's greenhouse gases. And so we've kind of like scrolled through this story, and you can play around with this. And this is, of course, super accessible on both like a computer and a tablet. Here's a little bit more extreme of an example, and that really like takes, you really have to read and understand what's going on here. So this is oil supply versus prices. So what we have here is a scatter plot. We have oil price on the right, and then the world production on the x-axis, and then we have like the scatter. The points in the scatter plot are different years. So we see that in 1996, oil prices were fairly low, but also production wasn't very high. And so like we can trace this, and this is kind of like a neat idea of visualizing this, but then we can kind of like change the perspective here. Now I've kind of like switched between year and month. So they're kind of like dynamically adding those dots. And then it kind of like switched now, it was a little subtle here, but you can see that they switched actually the axis. This is world oil production, and now I'm switching to OPEC production. And so I think this is like one of like the problems when we talked about perception and change blindness, right? Like every time I look at this visualization, it takes me a while to understand why did everything move around so much right now. Like the OPEC production here at the bottom really was a very subtle change, which I couldn't really trace well. And so there's a lot of like crazy animations and change of scale in here. So I think that this is an example that, in my personal opinion, overdid it in some way. And this storytelling here isn't really the best solution to the problem. So semantic zooming, I just mentioned this earlier, is this approach of like at different zoom levels you reveal different things. And you're all familiar with this from Google Maps, right? Like you start out like, with the world, you see the names of countries and the borders between countries. As you zoom in, you start seeing states and roads. And if you zoom in further, you start seeing buildings and businesses and so on. And so there's semantic information that is revealed as you zoom in. And this kind of like, there's many different applications. Like a map is an obvious one, but this is, for example, also integrated in Microsoft Windows. And so here, like a short video about this.
Hello, my name is Adam Barlow. I'm a program manager on the Windows Developer Experience team. Today, I would like to introduce you to Semantic Zoom Control, which is included as part of the Windows library for JavaScript. Semantic Zoom is a control used by apps in Windows 8 for displaying large sets of content in a true user-friendly format. Semantic Zoom is unique in that it provides an easy-to-navigate, touch-optimized view of the data you present to users. In designing Windows 8, we wanted to ensure users wouldn't have to pan tediously through large sets of content with touch. Semantic Zoom is our solution to this problem. It gives users the capability of quickly jumping to sections of the view and greatly reduces some of the pain points traditionally associated with large collections. As you can see here, Semantic Zoom allows the user to quickly jump to any given location in the view, in this case, the last group of my start screen. Not only is Semantic Zoom a great navigation mechanism, but it also allows you to communicate a higher level organization of your data, using the zoomed out or semantic view. For example, in the People app, you can zoom out. Here you will see a higher level abstraction of the data in terms of letters of the alphabet. This is extremely powerful and can be used to communicate important information to the users of your application. For instance, you can use the self-spanning functionality of the WinJS list view to demonstrate the relative sizes of your groups. Although Semantic Zoom is easily performed with touch using the pinch and stretch gestures, it also works well with mouse and keyboard, ensuring that regardless of input mechanism, your users will have access to the important benefits of both the jumping and presentation functionality. With mouse, you can use the Semantic Zoom button located conveniently at the bottom right of the view, and with keyboard, you can zoom by holding down the Control key and pressing the plus or minus keys on the keyboard.
So, does anybody use this on their computer?
What is Windows 8?
It's gone in Windows 10?
Yeah.
Okay, I've not used Windows for a long time. But like, what do you think about this? Is this a great idea?
Remember?
Well, recalling like when I used it, I found it very distracting, like finding stuff, and then like there was no like if you're on like a desktop or like a laptop computer and you didn't have a tablet, then it wasn't very effective. Whereas if you have when you have like the interaction with the tablet user interface, it's like much easier to use.
Yeah, I think it's unintuitive. It's something that you like. It sounds really nice and it looks really useful, but you have to train users on it.
Yeah. So anybody want to speculate why this might not be like the best implementation, at least?
I mean, if I want to find something in a large collection of things, I wanted to search for it. I don't have to like look through and try to find
There are more direct ways, right? Like I never use the overview feature on a Mac. I just like use like command space and search for the application. Right? This is like a much more direct way of doing this. And I think another weakness here is also that space isn't particularly meaningful. It's like there is no clear like what is to the left, to the right. This is not just like more or less arbitrarily arranged. So maybe if you like use this for a while and get used to where things are, it might be useful. But initially, it might be a little bit complicated. Here's another example from a research paper. This is about like a project where they did like systems monitoring.
Interactive visual exploration of system management time series. Visualization system reviewing large quantities of time series data in the domain of system management. Monitored devices are represented by rows. This label shows aggregated information about a group, manifests, with 4 devices. Columns show one or many parameters collected from the devices. This column shows CPU usage. In the current overview, each cell is a small colored block. In these 4 cells, green means CPU utilization is above 35%. As I make the cells larger, labels for the individual devices become visible. Also, when the cells get big enough, the server is queried for more data, and then the representation changes from blocks to spark lines. Making a cell even bigger results in semantic zooming to show a more detailed line graph. We can see the current time range by looking at the time boxes to the bottom left and bottom right of the data area. The blue lines show progressive search results.
So I really like this feature, right? That you start off with like a very compact abstract representation that's basically color-coded. Then you zoom in a little bit and you get these spark lines that gives you an idea of like the distribution of the data. And if you really want to show more information, like if you really want to analyze it closely, you zoom in further and then you get like legends that allow you to reveal details about the data set. So like another technique that is frequently used is focus and context. And the idea of focus and context is that you have like a complicated visualization, but you're very careful about picking what to show based on like a couple of different factors. For example, like what I'm currently interested in and what is relevant to that what I'm currently interested in. And then you hint at the same time at what you're not showing so that you give like context information. So the idea here is that you have like a synthesis of visual encoding and interaction where like a user selects a region of interest through, for example, navigation or selection, and the system provides context through like aggregation, reduction, and layering. So what do I mean by aggregation, reduction, and layering? This is kind of like how Tamara Munzner puts it in her book, elision, superimposition, and distortion. And so we'll talk about these now. So elision in, like if you're not a native English speaker, this is maybe not a word that you've heard of, but this is essentially what, like if I say don't, I'm eliding those two or leading those two words into one word. And we can do it like this is basically where this term comes from in visualization. So you show a focus item in detail and others are summarized for context. So here is an example of that. This is like a space tree, like a paper from 2002. So once you click on one particular node in this tree, you get more information about this tree. But if you click on another node, it automatically collapses what you're selecting. And like a generalization for this is what, like the degree of interest function. And the degree of interest function is something that I find very useful in like lots of projects. And in maybe like a little bit more, well, I'll talk about this more later. But essentially, what is this? This is based on observations as human. Often, like if you draw a map, for example, of your like where you live, you might draw a lot of stuff in detail around your house or around the university. 2 terms here. It has an API term and a distance term. And so the degree of interest of an object X is its a priori interest. Like how important is it, ignoring everything else just from the data, and what is the distance from Y, which I currently have selected. So let's suppose, like well, I'll show you examples here. So this is a DOI tree implementation, but this works for like lots of different things. So this is an interactive tree where we have animated transitions that fit within like the bounded regions of the screen, and then you can like select items and dynamically this tree will dynamically reveal those items and based on my current selection and its importance globally in the tree. And so of course in the tree globally important are things that are on your path to that particular node. And so what you then do is you create, for everything that you don't want to show, you create aggregate representations of these subtrees. So like here's another example from one of our own papers. Here we use a degree of interest function without like a distance function. These distance functions are like a little bit tricky, so it's sometimes often useful to simply say like what do I care about in the moment. So oh, it's gone. So what this here shows is, this is just like a tree visualization. What we want to do is we want to kind of like aggregate nodes because we have like lots of elements in the tree, but we want to reveal some nodes that are particularly important. And so we use a degree of interest function to do that. Let's wait just a second until we see the interface. So like here, like now I've completely aggregated, like these are like nodes in the tree, and then I've aggregated all of those elements here into little squares. But these are people, so I could say something like, these are people that publish, like academics, and so we could say, hey, we want to like really reveal the most prolific authors here, but not show everything. And we could simply do that by like submitting a query so that we kind of like only our degree of interest, like our a priori interests, are people that are very like prolific in terms of research. And so here's an example of how we do this. So this is now aggregated. Not yet. Now it's aggregated. And then you can select on a histogram here at the very top, what are the things that you care about? And so here, like this is like the authors that have lots of Chi publications, for example. And you can see that those authors pop out of this aggregated list based on this degree of interest that I specified. Another approach to do this is superimposition. So here, the focus layer would be limited to like a local region of a view instead of stretching across the whole view. And so this is here like a historic example with like a magic lens.
Toolglass sheets can include magic lenses, visual filters that modify the appearance of the objects beneath them. For example, this lens magnifies the objects underneath. We control the magnification with this slider, increasing or decreasing. This second lens is a filter that shows only red objects. Overlapping the two filters composes their effects. When we place the magnifier lens over the red object lens, we see that this little red object is a Time magazine. Magic lenses can be used to modify a scene's appearance in small regions, while leaving the rest of the scene alone as context. To move the Time magazine from the kitchen table to the nightstand.
Okay, so these things can be useful in some contexts. Here is an example for like how you can implement this with a tangible interface.
Up to now, table interactions are limited to the two-dimensional surface. In this example, users can zoom and pan through large pictures by performing multiple gestures on the table surface. In the following, we show how this task can be accomplished in a more natural way. For this purpose, we developed a table-based mobile display that users can freely move through the physical space above the tabletop. This magic lens works as a magnifying glass to zoom in on an image by simply lifting or lowering the lens. At the same time, moving the display horizontally results in a panning operation. In order to maintain the context, a circular contour line is projected on the table display.
Anybody want to guess how this is implemented? Two projectors. Two projectors, like one does what?
Full table display and one does the just magnification.
Exactly, and so what you'd have to do is track exactly where this object is, only like project from the top on that particular object. A simpler way would be to just use a tablet, right, where you have a camera and then kind of like tracks the position that way. That's like probably like, yeah, not quite as fast potentially, but that would be another way to implement something like this.
It seems like a lot of work.
It is a lot of work, and this is like these kinds of tangible interfaces. You don't really see them in real life, at least not yet, right? These are all research projects at some lab, and like part of that is also because they're really like strenuous, but there's a lot of technical complexity involved here. You could use a magic lens, like a very useful application of it would be labeling, right? So that you like when you have a lot of points that you can have a lens, and then you can label those points that are under your lens. So this is a little bit more efficient than just a tooltip because you will see multiple labels at the same time. And then finally, one other focus in context technique is distortion. And this is like the idea here is to use some geometric distortion, like in a natural lens of the contextual regions to make room for details in the focus regions. So here's like a pretty cool implementation of this idea. I can here visualize evolution of music genres. So I have like punk, death metal, indie rock, alternative, country, and so on. But I have like noticed that we have like a non-linear time here, and I can kind of like change what I consider to be in focus here. So I can move this around, and it will give me this geometric distortion and show me the elements of the of what is whatever is in this particular region in more detail, and then provide the rest here distorted for context. So this is a fairly elegant implementation. This can there is some kind of like historical projects that use this kind of idea. This is like a very early visualization paper from '91. I just want to show this for
the perspective wall is used to lay out 2D information onto a 3D segmented wall. The front segment is used for viewing details, and the side segments provide context. In this case, each node represents a file with its horizontal position determined by its date of last modification. Vertical position is used to indicate the class of the file. When a node is selected, the wall moves to bring the selected node to the center of the front section. As before, we have a fisheye view. We're using 3D to make better use of available screen space, and we use interactive animation to exploit the perceptual system's ability to track relationships between moving objects. In regions of the wall where there's too much detail, we can stretch the wall like a sheet of rubber to reduce clutter.
Okay, so basically you could like this idea of stretching like this, like a rubber sheet, and revealing more information is what happens if you use these kinds of distortions. So in a fisheye distortion, you kind of like get amplification at the center, but then you have to squish areas that are like just outside of your center, and then only there are some areas like on the far outside of your lens that are not affected by this distortion. So like people have done this to reveal things like hyperbolic geometry. Like if you want to browse a large tree, you could use some approach like this here.
The hyperbolic tree browser is a focus plus context technique for browsing large hierarchies. Here we see a recent org chart of Xerox PARC containing over 300 nodes. The root of the tree is in the center of the circle, and successive levels of the tree are closer and closer to the edge of the circle. The edge is kind of like a vanishing point. Spacing gets smaller and smaller as nodes approach the edge, but the entire tree is displayed inside the circle. The structure of the tree is prominent, even when some nodes are too small to display text. For example, staff positions can be distinguished from line positions. By clicking on a node, we bring it into the focus area. Thus, we can see more of the detail of that part of the org chart, while maintaining the context of the whole. We can also grab a point in space and drag it around as we like. To achieve crisp dragging, and to keep transitions under 1 second, rendering of the tree is degraded in a couple of ways. Notice that the arcs are turned into straight lines.
So the rendering approach here isn't particularly relevant. like in most detail, and everything else kind of like falls off the tree. Here's an extreme example of like a lens for a bus network.
With data provided by the Land Transport Authority, it is possible to monitor the activity of buses throughout Singapore. But, considering the large volume of information, exploring individual bus stops is a challenge for visualization. In order to achieve this, an interactive tool has been developed. It acts like a magnifying glass, allowing you to explore with great detail the activity of the bus network in Singapore. This magnifying glass...
Okay, so what do you guys think about this?
Why can't I use Google Maps?
I see a lot of shaking heads, right? Like, what's going on here? We have like a ton of distortion at the edges. So it's really hard to do this. So there are ways of like, if you have like a linear list, here's a couple of examples where that works fairly okay. But generally, what are your thoughts about this kind of distortion? I see like one thumbs down.
I think it depends on what your metrics are and how many of them are important. Like if you're trying to do it with a geographical space, then all of the metrics are important, and anything that gets distorted is going to make the view confusing.
Yeah, so what you're saying is essentially if I have like 1D list, it might be a good approach. But if I have 2D and I can't really show the context very well, then it might be a little bit more problematic.
The other problem that I have with this most of the time is you're zooming in to visually get details, but most of the time the movement of the mouse is still mapped to that very small detail. So you can run into situations where you move your mouse a pixel, but
yes,
stuff you look at.
Exactly, like picking stuff gets really tricky. So like these distortion-based techniques were kind of like a really hot topic 10 or 15 years ago, and people have like developed many different algorithms, and it's mathematically interesting. But in the end, I think the visualization community has nowadays recognized that there's lots of problems with it. So they tend to be unsuitable for relative spatial judgment. We have the whole overhead of tracking distortion. We have to somehow think about how we communicate this distortion. So we need like reticules or grid lines or shading or something like that. We have this, what you just mentioned, the target acquisition problem. Like I can't really click something because the lens displays items away from like a screen location. So if I try to click it, I have to really hone in and try and move around. And when people study this empirically, they have basically mixed results compared to separate views and temporal navigation. So it's technically very challenging. We don't really have evidence that it works all that well, but it looks cool, and that's why people like to implement it. But generally, I wouldn't necessarily recommend this for the general case. There might be some niche applications where it's super useful, but not that many. Anybody read Calvin and Hobbes? Like what transform modification in Calvin and Hobbes? He has this little box, and he can basically transmortify himself into whatever he wants, usually a dinosaur or something like that. This is a very cool paper, and I'm not going to say this is super useful, but it is very cool. From UST, that essentially lets you pick shapes and then distorts them into into a linear representation. So the person is tracing a river on a map, and then linearizes this river. detailed chart and they can make it into a bar chart. So this is a very nice demo, and I actually got to play on this table once. It is pretty cool, and of course, if you have questions like which is the longest river in the United States, you can just trace the rivers and then straighten them, and then you have your answer. Okay. Overview plus detail. That's something like anybody like who plays any of these like role-playing games. You probably have seen something like this. This is like Warcraft or no Diablo. Warcraft 3, yes. Warcraft 3. And so you have like one view on your character, which gives you detail, and then you have like a big map that allows you to quickly navigate. So here you have like your overview in the map on the left, and your detail in the map on the center. Google Maps used to have this. Like back 10 years ago or 5 years ago, they had like a small map of the world and give you context. Why do you think they've done away with this?
Well, they kept it, right, with Pac-Man?
With Pac-Man?
Pac-Man. You drop down and then you...
But it's not at the same time, right? You can basically like pick Street View, but you don't see two maps at the same time, and this is what I tried to get here. Any other ideas why Google Maps doesn't have this feature anymore?
You probably don't need to know like what area of the world you're in if you know like you're looking at something.
Exactly. So you like it. This is different, right? You want to jump between different positions on the map very quickly. In Google Maps, it's unlikely that you kind of get lost of what you're looking at, because usually you're looking at your environment or maybe your vacation destination, but you still know like where Hawaii roughly is. So it's not that important, and you don't need to quickly jump between different places. Here's another example, the film finder, which is like a historical example where you have like the background gives you kind of like the overview, like a scatter plot, and then you have like a tooltip, basically an advanced tooltip that shows you the details about one of those items. And again, this is like something that we now kind of expect, but back in '94, that was like a cool idea. And then filtering and dynamic querying, which is also called brushing brushing and linking or selecting, is one of the most important interactive operations. This is Ben Schneiderman. He's like one of the founding fathers of visualization. You've seen like some of his work already, and he's also a very famous ACI person. And his most cited paper is actually like a position paper from '96. And in this paper, he says like the information-seeking mantra is overview first, zoom and filter, then details on demand. There's also relate, history, and extract, but these are the points that stick. So this is kind of like an idea of, for certain data sets, how you would explore something. And so he came up with like this dynamic query interface. So like, I want to show this video briefly. This is
again, the principle is to visually demonstrate the query components and the results and provide rapid and immediate feedback. For that, I'll take a look at the demo here on this display. Just move over to the side here, and we see on it a map of the Washington, D.C. area, which is shown here. And this is an improved version of where we were a year ago in terms of dynamic home finder. The scenario I present to you is that we're coming up on a new administration, and you've taken a job with the Clinton administration, and your spouse is going to be working at the University of Maryland. You're looking for a home. So the first thing to do is to mark where you want to work here at the University of Maryland, right about, let's say, there, the A marker. And then your spouse is going to work downtown in the executive office building, right about over there. There's the B marker. Okay. And now each of these points of light on the display represent a home for sale. And if I move to the right, I can control this display by choosing the distance that I want to be from point A. And now it's set at 30 miles, and I'm going to bring it down. And you can control rapidly, incrementally, and reversibly the distance that you wish to be from point A. So let's say you decide, you see there's plenty of them, so you say you want to be, let's say, 5 miles from work, so that you could, let's say, bike to work. And now you want to be somewhere inside that range from B, so you slide down and we now can see the set. And this is, looks like we've got 40 or 50 homes over there. If I now choose about the number of bedrooms, I really want 3 or 4 bedrooms, so I move this double box slider to be 3 or 4. I've still got about 30 houses on the display. So why don't we look at the price now, and we want to keep the price down, let's say about
okay, so prices have changed. But this is like clearly an example of indirect manipulation, right? Like you have these sliders here, and back then it was a technical limitation. I did prepare a redesign exercise for you guys to make this into like a direct manipulation interface and a couple of additional questions, but we're kind of running out of time, so I'll just wrap up the content and do this redesign exercise next time.
So this is like Amazon?
Yeah, so it is a little bit like Amazon. Like here, this example on Amazon, we use like faceted search, right? So we like say, hey, if I want to pick a television, I can do things like I only want things that have like an average customer review of at least 3 stars, and then I need it to be 70 inches or more. And I want to spend like at most whatever, like $800. Let's see whether I get anything for that. So this kind of like search interfaces, there's a lot of research on the merits of these search interfaces. This is like fairly static, right? I could have like sliders here in some way to do that as well. So this is the exercise. I'm going to skip over this. And like now we can do these visual queries in like more intricate scenarios. This is this parallel coordinates plot, and we'll talk about these in detail when we talk about tableau visualization. But essentially what this shows is like different attributes of a series of cars, like the fuel economy, number of cylinders, displacement, horsepower, weight, and so on. And kind of it is possible to kind of trace like, okay, there is an inverse relationship between economy and the number of cylinders, but it's really hard to trace what's the relationship between miles per gallon and weight. And so what I need to do here is I need to brush and highlight those elements, and then we can see, okay, there seems to be also an inverse relationship between a fuel economy, cylinders, displacement, power, and weight. And of course then like a linear or like a direct relationship between fuel economy and the length of like how long it takes to accelerate. So slower cars are more efficient. And that's something that I can see at a distance here by simply using those brushes. We can do this in like, we can do rectangular brushes on like line charts or parallel coordinates like this, or we can even define these kinds of brushes in 3D. So I can say, like this would be like pathways in the brain, and I can say I really only want to see the pathways that run through the brainstem here. So I could like move a physical 3D object around here, and then I get only those paths selected, and then I can refine these brushes here on the right. You've also seen this already in the baby name wizard, like we have incremental text search that I showed in the very first lecture. And then of course I have query interfaces. So this is also very similar to faceted search, and going back to this tool again, and I switch to an interesting data set. And then here I can now say, like, I really want to see like what are the movies that are action and adventure but not children movies. And that kind of like now gives me a specific answer to this query. So this is just another way of like defining a brush or a selection through, in this case, a dynamic query interface. Okay, so I'll talk more about filters and interaction after the full break. We'll talk about designing next Thursday, and then we'll have the layout lecture on Tuesday. I'll see you guys then.